Hi, I'm an old guy and I do maths. Today we're looking at the graph of a sine equation. This is a sine graph, but it's not the sine graph that you might be used to. First of all, let's just have a look at some of its features. It has been translated down by 1 unit. Normally the median of a sine graph is not -1, it's 0. What else is there? Well, if I just get another sheet of paper, just excuse the noise, and draw a sine graph here, just very, very roughly and quickly, 2 pi, pi, and 0, you'll see that a normal sine graph, an ordinary sine graph rather, has a period of 2, and it's positive between the start of its period and halfway through its period. Thereafter it's negative. Now, if we look for the period of this thing, we probably are best to start here and finish here. And we can see that this thing goes through one cycle and winds up where it started in terms of the y-axis. And the period of this thing is 4 pi, which I will note. Period equals 4 pi. So what we know is that this has been distended along the x-axis. But another thing has happened. If you can just compare this graph with this graph, you'll see that there has been a reflection in the median. I won't say the x-axis, but the median. This thing, instead of this being here, it's here. So were this thing not reflected, this would be 2 pi 0, and this would be 4 pi -2. So we know that much. So let's see what we've got. We've got a reflection of this, and before I put a number in here and do anything else, I want to check the amplitude, which is 1. So in order to deal with the reflection, all I need to do is put a minus sign, because the amplitude is 1. That has not been changed on this graph. Now, we know that the period is 4. And so there is a number that goes in here to reflect that change from y equals sine of x. So I'll just work out that number. Now, the period of a sine graph is 2 pi on n, and in this case that equals 4 pi. So 2 pi is going to equal n times 4 pi. 2 pi on 4 pi is going to equal n. They cancel, so n is going to equal 1/2. So we'll just park that there for the moment. There's one other thing to be aware of. This thing has been moved to the right, and we need to be careful about how we account for that. So what I tend to do is I tend to take care of this translation at around about the same time that I take care of this translation, and then, having noted what the period is and how I get the period, I make my final note here. What am I saying? Why am I saying this? Right. So let's just assume that we have not got the translation in the positive direction of the x-axis. Let's just assume that this thing starts over here at 0, and that it does this, and that this is 2 pi, and that this is 0, and that this is pi. Now, if I want to move this to the right, all I have to do is put a negative sign here and some measurement in radians here. Now we know here that this thing moves pi radians to the right. Now if I move this graph, which is y equals negative sine x, if I want to move this to the right, I can do the following. Now, I don't want to move this all the way to pi, because the next thing that I want to do after I've made all of these changes is that I want to elongate this. I want to double the period. So I'm going to move this pi on 2. And what I get is this. And this is, that's 4 pi on 2, that's 5 pi on 2. And this is pi on 2. Now, what happens if I change the period? Well, what happens is this gets stretched along this axis, and I'll just show you on this piece of paper here what happens. So this is what we've got. We've got 5 pi on 2 here. We've got the critical measurements are pi on 2 and 5 pi on 2. Now, if we apply this 1/2 times x to increase the period, what happens is this moves to pi, this moves to 5 pi. We still have the basic shape, and there is our graph. So, how do we account for all of this? Well, this is indeed 1/2 pi, but it is minus pi on 2 because of the distending feature of this. And it has been moved down 1, so it is that. Now, that is our equation, and that is how we go about getting it. It's not the only way, but it is an understandable way of doing it, working from a graph. And the key thing to be aware of is that this part of it can trip you up. So before you go working on the period, take account of this. Take account of the translation to the right or the left, if there is one. Okay, well, look, thank you very much for watching. I hope you found this useful. If you did, please like and subscribe, and I will see you next time. Bye.